Okay, this is the Chapter 8 handout from class, and I am going to do problems 11 through 15. So we want to simplify each expression. Assume all variables represent positive real numbers. Write the answers with only positive exponents. When we simplify radicals, we want to minimize what's under the radical sign. Also, no radicals or imaginary in the denominator. So for number 11, we are multiplying. Multiplying, absence of an operator, this number times this number. Looks like a polynomial, treat it like a polynomial. Double distribute. Multiply 3 square root of 7 times 5 square root of 7 minus 6 plus 2 times 5 square root of 7 minus 6. Actually, this one was distributed among this set of parentheses, and the second one is distributed among the second set of parentheses. So this was my first step. Now I'm going to just distribute normally. So that's why we call it double distribute. When we multiply these numbers, we need to multiply the outsides together and the insides together. So we have 3 times 5. I'm just kind of move them together. Square root of 7 times square root of 7. All those things are multiplied together. The next one, we have a minus 3 times 6 square root of 7. That's the first set. Now for the second set, we have 2 times 5 times square root of 7 minus 12. That's it. What is square root of 7 times square root of 7? That's just 7. So the first one, the first term is 3 times 5 times 7. The second term, these two go together. We have negative 18 square root of 7. The third term, these two go together. You have 10 square root of 7 minus 12. This is an integer and this is an integer. So they can be combined, or more likely they're rational numbers. They can be combined. So 3 times 5 times 7 is 105. I'm going to combine that with this one over here. So I'm going to say minus 18. And then I'm going to combine these two. Like radicals, add or subtract combine the coefficients. Minus 8 radical 7. I just need to combine these. 105 minus 18 is 93. For this term, 8 radical 7. For number 12, in the way it's division. Let's break this up. Square root of 7 over square root of 40. We are allowed to do that when we have multiplication and division inside the radical, because the radical is really a power of 1/2. No radicals or imaginaries in the denominator, which I have. How do I get rid of that? I need to multiply by radical 40. This will clear the denominator, but the numerator has to go along for the ride. So in the denominator, we have radical 40 times radical 40, which is just 40. In the numerator, we have, okay, they're both in a radical, so we need to multiply what's inside the radical. What we end up having is radical 280. That looks rather big. So there must be, we gotta check to see if there's any perfect squares in there to pull it to the outside. Let's factor 280. 280, let's start with 10. And 28, you could start anywhere. Just keep breaking them down until you have all primes. Okay, so I'm going to rewrite this as the square root of 2 times 2 times 2 times 5 times 7. All over 40. So this has been replaced, has replaced the 280. I see this is a perfect square. A pair of 2 comes out as 2. These don't have any pairs, so I could actually just multiply them back together to make it look nice. Over 40, and I hope you can see that you can reduce that to square root of 70 over 20. Divide the numerator and denominator by 2. Square root of 70, it looks big, but I know there is no perfect squares in it. Question number 13. Give me a minute for that one. You can pause. Question number 13. No radicals in the denominator. I need to clear this. In order to do that, I need to multiply by its conjugate. Oops. But in essence, I am really just multiplying by a form of 1. This is what I started with. Multiplying by 1, I should end up with the same expression, an equivalent expression. So this is just 2 times this polynomial numerator, which becomes 2 radical 5 minus 2 radical 3. The denominator, we'll work on that together. The whole reason why you multiply by the conjugate is because this comes from the difference of 2 squares. The middle term here is positive square root of 15. The outside term is negative square root of 15. So they cancel. So the inner and outer products cancel. The first product, square root of 5 times square root of 5, is just 5. The last product, square root of 3 times square root of 3, is just 3. Of course, that's going to be a negative. So what we end up here is 2 square root of 5 minus 2 square root of 3 over 2. I see lots of 2's going on. We need to share this denominator. Divide each of these by 2, which gives us square root of 5 minus square root of 3. That's it. Cube root of 4/5. Like we did above, let's break this down to the cube root of 4 over the cube root of 5. So in order to get a perfect square and clear the radical in the denominator, or the cube root in the denominator, I have 1 5 under there now. I need triplets to come out of the denominator. If the indices match, we can multiply under. So in a way, I need another 2 5s, so that in the denominator, I will have 3 5s. 3 5s come out as 1. So, backing up, just to show you what's going on in the denominator and why we're picking that number. Okay, this is what I started with. I am multiplying by 1. That's the denominator. I need to do the same thing in the numerator. We know 5 times 5 is just 25. So we've got matching indexes. This is 4 times 5 times 5. You know, I'm going to put them in like that. 4 times 5 times 5. Next line. Cube root of 100 divided by just 5. This triple comes out as a 5. That's it. And last in this set is square root of 2 times the cube root of 3. This one's a little tricky. I just can't multiply the 2 and the 3 because they're not the same index. They're not in the same basis. The easiest way to see these is to actually change them to the exponent notation of radicals. So it's 2 to the 1/2 times 3 to the 1/3. You know what? I'm looking at my notes here. I see that I had you guys omit this. Had you omit them. Okay, so we're going to omit this one. And that's it. Chapter 8, numbers 11 through 14.